In this video, I'm going to go over the formation of imines and enamines, which are going to be two compounds formed from the reaction of an aldehyde or a ketone with a nitrogen nucleophile. So I'm going to start with imine formation. So imines are common molecules in biological pathways, so they're going to be important for organic chemists. The general structure of an imine is as follows. Now these R groups down here, they could also be hydrogens, right, if you have an aldehyde. So that's the general structure. So the mechanism involves 6 steps in 2 parts. And we form this imine through the reaction of an aldehyde or ketone with, and this is important, a primary amine. Right, the primary amine is going to be, draw that a little better. The primary amine has 1 R group, 2 hydrogens, in a lone pair. That's the nucleophile that reacts. It has to be a primary because if it's not primary, that will be a different reaction. So here's the mechanism. I'm going to use that as my aldehyde. All of these steps are in equilibrium. So it's in equilibrium with my primary amine. Amine will come in and attack the carbonyl carbon in a nucleophilic attack. In this imine formation, it's really important to make sure we're keeping track of all the formal charges because they're going to change a lot since there's a lot of proton transfers. So next step is going to be a proton transfer. We're going to protonate the oxygen. So the group that's protonating it is going to be an ammonium ion. And I'll go over why we have this ammonium ion once we go through the mechanism. But that gets deprotonated by the oxygen. So now I have an OH group. And then I still have a positive formal charge on the nitrogen down here. So the next step now is going to be another proton transfer. This time, I'm going to have the deprotonated primary amine, and it's going to get protonated now. And I'm left with that. This here is called a carbinolamine. So the carbinolamine, now another proton transfer. To protonate the OH group. To make it a good leaving group. So now the lone pair on the nitrogen will drop down to form a double bond and kick off the OH2 group. So now form that. Final step is going to be a deprotonation. And I end up with my imine. So there is my imine. So that is the mechanism. Notice a lot of proton transfers. That's the majority of what this mechanism is. Right, so walking through the steps, first part 1 is the formation of the carbanolamine. Formation of the carbanolamine. Step 1 is nucleophilic attack. Step 2 is a proton transfer. And step 3 is a proton transfer. Right, step 1, nucleophilic attack. Step 2, proton transfer. Step 3, proton transfer. So part 2 of it is now going to be the formation of the imine. So step 4, it's another proton transfer. We had a proton transfer there. Step 5 is the loss of the leaving group. In this case, the leaving group is water. And then step 6 is another proton transfer. So this is how we work through every mechanism that has to do with an imine formation. Nucleophilic attack at the primary amine, then 2 proton transfers give you the carbanolamine. Another proton transfer, then you lose a leaving group, proton transfer, and you end up with your amine. Now we use a small amount of HCl to help catalyze this reaction. But the reason it's not HCl that's acting as the protonating agent and it's the ammonium ion is because we have reaction between HCl and our ammonium ion, or ammonia, primary amine, right? To give us Cl minus and then that. So the reason that this one is favored is, if you remember, this isn't even equilibrium, right? Because it's a strong acid. But we're favoring whatever has, the weaker acid and the weaker base. The pKa is equal to -7 for HCl. The pKa of the ammonium ion is about 10. So it's much less acidic. So you're going to see a lot more of the ammonium ion in solution than you will of the strong acid HCl. Now, another thing to consider with the imine formation is that it's pH sensitive. It runs at about a pH of 4.5 is ideal. Right, if we have too low of a pH, so it's too acidic, our issue is going to be with step 1. We're not going to have very much of the primary amine to act as the nucleophile because most of it's going to be protonated since you're at a low pH. But if our pH is too high, so now we're well above 4.5, My issue is going to be more with step 4 here. I have to protonate an OH group to make it a good leaving group, but if the conditions are too basic, it's going to be very difficult to protonate that OH group. So this is one of those reactions that is very pH sensitive in terms of it working or it taking a really long time or not working at all. So part 2 of the video will be on the formation of an enamine. So be sure to check that video out.